Hey YouTube, Jake Kilroy back from Christmas, and we're ready to finish up, or at least continue work on the Sjogren chuck rebuild. I want to get that thing done, get it out of my hair, and move on to other projects. So I'm going to move the camera over the lathe. I've got the center gear in the chuck with the insert that we previously made. Locks had it in place. It's had plenty of time to dry the whole week while I was off here, and we're going to get to work. So let me move it on over there and we'll get after it. Well, we've got the gear chucked in here. This is our insert with the 1.5 inch OD, and it's quite a bit proud of this back and needs to be flush. So our first order of business is to trim that down. Drop on a facing tool here. Okay, the first thing we'll do is I'm going to bump my tool block up against the workpiece just to make sure that we're square. Got my turning facing tool in here. This is just a very simple TPG style insert, and we don't really know exactly how much cut we can take on here as far as not wanting to damage our Loctite bond. So I'm going to start off here pretty light, and we'll work up to it. Okay, we're getting kind of close down to it here, so I'm going to set up a A-bomb 79 approved mag base, one of these little puck mag base indicators, and I'm going to go ahead and reference my cutting tool off of this face, which is what we want to be parallel to get a 0, and then I'm just going to work back to that 0. So go ahead and just touch it and set an indicator and 0 it, and then we can just work back to it. So let's do that here. Check it out. Right on the money. That's perfect. Alright, we're going to go ahead and this is the side I'm going to thread from. So we're going to do the internal thread from this side, even though this is the back side of the gear. I'm going to thread from the front to the back. I'm going to thread away from the chuck, running the lathe in reverse with my cutting tool on the back. But the first thing we got to do before we can even get to that point is we've got to get our bore where we need to be. Alrighty, let's go ahead and oops, put the wrong one there. Let's see. that up. Okay, that's measuring 1.015, and I need to be at 1.188, so we got a good bit to take off here. Alright, taking a little scratch cut there just to zero our dial, get everything zeroed up here. And we're going to pop in here and get us a measurement. Okay, 1.013. And we need to go to 1.188. Alrighty, we got to take off about 173 thou to get our bore right. I've got a dial indicator set up here on the cross slide. Let me show you that kind of clustery arrangement. I don't have a real good way to pick up a dial indicator here, so what I did was I stuck one dial indicator on the cross slide, and then I stuck this dial indicator up against that one and dropped the lathe into neutral here and ran the cutting tool all the way through and made sure that the chuck jaws and everything missed all my components and weren't going to send parts flying about the shop. So this basically brings up a new project to do here, which is I need to make a adjustable rod stop on the tailstock end here that I can use for things like this. I mean, a DRO would be better, but I'll go with that. So we're going to put you back in here, and we're going to get started, and we're going to take off. We're going to start taking some cuts. Like I said, we got 173 to take off, which is plenty, and we're going to start from there. Alrighty. Let's get another measurement here. We should, according to my dial indicator at least, we should have taken out about 60 thou. Alright, we've taken a few cuts here. We've gone ahead and made a measurement check, and we've taken off just a touch under 100 thou. We've got 76 thou total left. I've slowed my feed down now. I'm taking a fairly slow feed of 2.3 thou, about 2.5 thou per rev, trying to get a really nice finish here and give me a nice smooth surface to measure on. My previous feed before that, I was feeding it about 5 thou, and it was a little rough, a little tough for me to measure. I've got 76 total left to take off, which is 38 on the dial. So we're going to start working back to it. All right, let's check our dimension. We ought to be quite close. And we're going for a target dimension of 1.188. And let's see what we got. All right, well, there's my measurement. We were going for 1.188, and the Mitutoyo never lies, baby. 1.18815. It's just ridiculous that I even own tools this good. But anyway, there we are, 1.188. I'm happy with that. I will take that all day long. Let's get a boring bar to do some internal threading setup, and let's cut some of these 20 pitch threads. Alright, we're set up here with our old school Armstrong boring bar with a 3/16 high-speed steel bit with a fresh point on it here, set on center height. Blued the bore so we can take a scratch cut. Before we get going, look at the setup on the machine here. Right here, I don't know if many of y'all are familiar with how a Revette 1020 is set up. We're in threads. We pick out our number, 20 threads per inch, and that is position 4 on the dial, and positions 2, 2 on A and B. A is set to 2, B is set to 2, and this is position 4, which basically locks in our thread there. And we are in threading, so we're going to go ahead and set up here, and we're going to take a scratch cut and check it with our thread gauge. Run this back around to 0. And fire up. In reverse, because we are cutting on the back side. Running in our first back gear ring. Wait for a whole number to come around. Let's spin it on out. All right. Get our thread gauge in here. Looking at 20 TPI. You're right on the money. Now, if you're ever threading with a Revette like this, and your threads are coming out double what you're expecting, then you're in the feed position, not the thread position. That's basically a 50% speed reduction. Selector is what that is. So let's back it back off. I got my dial indicator set here. Come back in and we're going to take our first cut. And we're going to take a 5 thou cut. Alright, fire it up. Plenty of lube on the seam. Wait for a whole number to come around. Whoop. Almost made a mistake. Add it forward. That would have been bad. Here we go. Okay, I'm trying to get some light in here so you can see. I've made a few passes. I'm starting to get a nice well-formed thread there. Looks good. It's still a bit tight when I use my thread gauge, which is a brand new 5C collet. It starts, but it's a bit snug, so I got to make a few more passes here. Well, there you go. I really took my time threading on this. I didn't want to bore you with pass after pass after pass, but I just did a radial infeed straight in, which is normally how I do threads of this size. Bigger thread, 8 TPI, 12 TPI, I do a more traditional compound feed, but there we go. So I'm going to pop it out of there, and so we can take a look at our part. So here's the side that will be presented to the, I'll do some cleanup here. This is the side that will be presented to the collet. And, nice firm fit, which is what we want. Unlike the factory part, I just threaded it all the way out through the back. The factory part only threads in about a ½ inch, but this is easier for me to do this way. So let me get this cleaned up, and then we'll go about doing our reassembly and trying this out. Alright, we're back. We're mounted in the lathe here. I got a collet cleaned up here. Find the pin. This is the hard hinge method for mounting the index pin, slanted in so you know which way the where the index is. Lock the spindle there. Go. Alright, that seems to work much better than it did previously when it wouldn't close a collet at all. So I'm going to call this little repair finished, and on to the next project. Yep, nice and firm. So there we go. Little internal threading, a little boring. It was boring, all right. This chuck is resurrected. Like I mentioned, the parts for these chucks are available from ATS Workholding. Link in the description. These chucks are available from ATS Workholding in all shapes and sizes. These were made in various 3C, 5C, 2J, 3J, 1J, different collets, much bigger than this. And a 2J would actually be better fit for this machine because a 2J goes up to 1 in 375, which is the same as the spindle bore, but 5C is what I got. So anyway, all these parts are available. This particular part was available for $200, which actually I think is pretty reasonable for the cost of that entire gear. But I managed to fix it with a little time, elbow grease, and about $3 worth of scrap stainless steel. So anyway, we're good to go, and I'll get this posted up and be back with you soon.